Ever wondered how to optimize LINQ queries in NetCore? Well, you're in the right place. Let's unravel the magic of Language Integrated Query, or LINQ, a powerful feature in .NET Core that enables developers to query various data sources in a readable and concise manner. But here's the catch. Inefficient LINQ queries can be performance bottlenecks, especially when dealing with large datasets or complex operations. Imagine querying a massive dataset and your application slowing down due to excessive memory usage or extended execution time. Or think about querying databases with Entity Framework Core, where optimized queries are vital to prevent unnecessary data retrieval and to leverage SQL Server optimizations. And it's not just this. In performance-critical applications like real-time data processing or high-load web applications, optimizing LINQ queries is more than essential. Now that we understand the importance of optimizing LINQ queries, let's dive into some practical ways to do it. First, let's talk about some common mistakes developers make while using LINQ queries. One classic error is retrieving all data. It's like going to a library, hauling every book off the shelves, and then deciding which ones you need. When you use methods such as toList to pull all records from the database before applying filters or transformations, you're essentially doing the same thing. This approach can stress your system, particularly when dealing with large datasets, and slow down your application. Secondly, developers often execute multiple queries within loops. This is akin to making separate trips to the grocery store for each item on your shopping list. It's an inefficient use of time and resources. When you run LINQ queries within loops, you end up making multiple database calls, which can significantly impact performance. Lastly, many developers ignore deferred execution. It's a powerful feature of LINQ that allows you to delay the execution of a query until the data is actually needed. Not understanding this concept can lead to inefficient query execution and unexpected results. It's like cooking a full meal when you're not even sure you'll be hungry later. Avoiding these pitfalls can significantly improve the performance of your LINQ queries. But what else can we do? Now let's move on to some best practices for optimizing LINQ queries. Firstly, always remember to filter first. By applying where clauses before other operations, you reduce the amount of data that needs to be processed. For instance, if you need only active users from a list of 1 million users, applying the where clause first will ensure that subsequent operations are performed only on the active users, thus improving performance. Next, consider using projection. The select keyword allows you to retrieve only the required fields. So, if you only need the name and email fields from a customer record, use select to retrieve just these fields. This reduces the amount of data transferred and processed, offering a significant performance boost, especially when dealing with large datasets. Thirdly, avoid premature materialization. This means you shouldn't convert queries to lists or arrays until absolutely necessary. For example, calling toList on a query retrieves all the records from the database at once. If you only need a few records at a time, this can be very inefficient. Instead, delay materialization until you actually need the data. Lastly, but certainly not least, understand deferred execution. This is a powerful feature of LINQ, where queries are not executed until the data is actually needed, like when calling toList. This allows you to build up complex queries in a readable and efficient way without worrying about unnecessary database hits. However, it's also a common source of confusion for developers, so take the time to really grasp how it works. Let's illustrate with an example. Suppose you have a LINQ query that filters out inactive users, sorts the remaining users by their last login date, and then retrieves the top 10 users. With deferred execution, this entire query is not run until you actually need the data, say, by iterating over the results or calling toList. This can lead to significant performance improvements, as unnecessary operations are avoided. By following these best practices, you can write more efficient LINQ queries and improve the performance of your .NET Core applications. Let's recap what we have learned today about optimizing LINQ queries in .NET Core. LINQ, or Language Integrated Query, is a powerful feature that allows us to query data sources in a readable and concise manner. However, inefficient LINQ queries can create performance bottlenecks, particularly when dealing with large datasets or complex operations. Optimizing LINQ queries becomes particularly important when working with large datasets, performing database operations, and in performance-critical applications. For instance, when querying large datasets, an inefficient query can significantly slow down an application due to excessive memory usage or prolonged execution time. Similarly, when querying databases, especially with Entity Framework Core, it's crucial to ensure queries are optimized to prevent unnecessary data retrieval and to utilize SQL Server optimizations. However, it's also important to know when not to over-optimize. If you're dealing with small in-memory collections or simple data processing tasks, extensive LINQ optimization might not yield significant benefits. Additionally, sometimes prioritizing code readability over performance can be more beneficial if performance isn't a major concern. We also discussed some common mistakes that can lead to inefficiencies, such as retrieving all data using methods like TOList before applying filters or transformations, executing LINQ queries within loops which can lead to multiple database calls, and not understanding deferred execution, which can result in inefficient query execution and unexpected results. To avoid these pitfalls, we reviewed some best practices. Firstly, it's beneficial to apply where clauses before other operations to reduce the amount of data processed. Secondly, use select to retrieve only the required fields, which is known as projection. Additionally, avoid converting queries to lists or arrays until necessary to prevent premature materialization. And lastly, understanding deferred execution can be used to your advantage for efficiency, as LINQ queries are not executed until the data is actually needed. Remember, the key to efficient LINQ queries lies in understanding the nuances of query execution and using the features of LINQ wisely. Happy coding!